Hello guys, my name is Mohsin Mullah and I welcome you all to this very interesting video lecture on block diagram of generic microcontroller. In this video we are going to look at what are the various parts of the microcontroller. So now microcontroller is a very interesting device and also a very important device without which we cannot even imagine most of appliances that we use in our day-to-day life, such as washing machine, microwave oven, digital camera, or nowadays motorcycles, automobiles, etc. All of these definitely contain an electronic device which is called as microcontroller. So basically this microcontroller is used to control various tasks that are expected out of those appliances, be it controlling the speed of the washing machine drum or controlling the temperature in a microwave oven or any other such activities that can be performed with the help of a simple electronic device which is called as a microcontroller. So the name micro suggests it works at a speed of microseconds basically, and controller because it controls various input output devices. Okay, so therefore it is called as a controller. Now what does it exactly consist of? So every microcontroller basically consists of three main fundamental parts. So here we can clearly see there are three parts available, and these parts are nothing but the very first part is called as the central processing unit or CPU, and then there is second part which is also an essential part for every microcontroller which is called as a memory part, and then there is a third also very important part which is called as IO ports or IO system. Okay, so now here these three fundamental parts make every microcontroller. So this is not specific to any particular type of microcontroller, but it is a generic block diagram here that we are considering. So central processing unit is basically used for processing various data. So simply if you want the a particular appliance to perform certain task, then there has to be a controller which can control the various tasks, and that part is done by this particular part which is nothing but the central processing unit. It acts as a brain of the entire appliance or the electronic device. Then there is memory. So now every appliance that we use, so you can see that there will be different types of parameters mentioned on the control panel. If you see a washing machine, so there will be different modes of washing machine, like for cotton it will be different, for silk it will be different, for jeans it will be different. So what exactly is actually mentioned at those particular positions of the knob? So here when you have a knob and a particular position is mentioned, so here, so basically for this there is certain codes are written that the speed of the motor should be such a value, and the time for rotation of a drum will be a certain time. Okay, so like this different parameters are already set inside, and these parameters are stored in the this particular part which is nothing but the memory part. So here CPU will definitely has to make use of this memory part in order to perform whatever tasks it has to perform. Without this memory, CPU alone cannot do anything. Okay, so now later on we have the IO port. So now what is this IO port's function? So IO port is a very important part of the microcontroller, because this particular IO port part will be used to interface various input output devices. Now whatever control panel that we see on washing machine, so it will have a knob and a display. So now this knob and display is directly connected to the microcontroller. So this display is nothing but the output part, and this knob that we use to select different modes is nothing but the input part. Okay, so these two are to be connected to the microcontroller. We want to give the instruction to the appliance to perform a certain task, then we have to use this knob which directly is connected to the input port, and then whatever we want the particular appliance to do, so that will be displayed on this display part, so which is again obtained because of the output port. So that is the role of this input output port. Okay, so this is basically, you can understand that in order to have a particular task carried out, so you need to give the instruction. So that instruction will be obtained from the memory location, then that based on that instruction, so the CPU will give the command to the input output port to either accept the input or to give certain output. Okay, so here, in order to carry out these all tasks or activities, these three parts need to communicate with each other. So CPU has to identify particular instruction depending upon the whatever input is given. So therefore, this CPU needs to be having communication channel with the these two devices. Therefore, here we are going to use electrical lines or electrical wires which are called as the buses. So basically, buses are nothing but the bunch of wires which are used for obtaining certain information or data from the memory location. And the so here basically we have three buses. So the first bus is called as the address bus. So here this address bus will be carrying or used for the transport of the addresses for the memory and the input output port. So here we have to select a particular port, so there will be multiple ports available, so address of that port needs to be obtained. So therefore we are going to use this address bus. Okay, so this address bus can be 8-bit or 16-bit. Means what? So here whatever information will be there, so we know that it will be in the form of zeros and ones. So here the bus can be having lines which can carry 8 different digits, zeros and ones, or if it is a 16-bit, then it will have 16 lines to carry zeros and ones, and using different combinations of those zeros and ones, we have the different you can say location codes available in the memory, and also for the IO port certain codes will be reserved. Now sometimes what will happen, so for if you take an example of a microwave oven, so in a microwave oven we sometimes set the temperature. So we set the temperature, say here sometimes we set it at 100 degrees, sometimes we set it at 110 degrees. So likewise, so now this is called as the data. Okay, so this is nothing but a variable, so which is going to change depending upon our requirements. So now this data also needs to be here accessed by the CPU, as well as certain data it has to also give as a output. Okay, so therefore there has to be another bus which is called as a data bus. So data bus is used for carrying the data to and from the CPU to the input output port, and then to the memory also. Okay, so the memory has got two parts. One part is for storage of the addresses, and another part is used for storage of the data. Okay, so we'll talk about it in a bit later. So this is nothing but the data bus. Okay, so data bus, so this bus is used for transportation of the data between CPU, memory and input output ports. Okay, so here data bus can be 8-bit, 16-bit or 32-bit. So same explanation goes for the data bus also. If it is 8-bit, it will have 8 lines to carry zeros and ones, 16-bit will have 16 lines to carry zeros and ones, and 32-bit will have 32 lines to carry zeros and ones. Okay, so that is about the data bus here. So let me just move it here, because we have to show another bus. Now there is a requirement of a control bus, because here for example, if you want to select any port as input or output, how is it going to be selected? So for that there has to be some command that will be given to that port to act as a certain port as input or output. So therefore here we are going to have another bus which is called as control bus. Okay, so which is called as a control bus. So this control bus is again connected between the CPU, the memory and the input output port. So what does it actually carry is the commands or control signals. Basically it will carry the control signals. So here in this particular topic we are not going to discuss much about the different control signals that are required, but in simply I can tell what exactly these control signals can be. So sometimes it can be a write instruction, sometimes it can be read. So write means it is going for the output side and this is going for the input side. Okay, so like this is one example of the control signal. So such different control signals will be there, so that we will see in the later part. Okay, so here I hope you are understanding what exactly is the microcontroller consists of. So basically it will consist of a central processing unit, memory and input output ports, and for communicating among each other they have got three buses. One is the address bus, then there is a data bus, and then there is a control bus. So this particular bus is called as a control bus. Okay, so these are the you can say main description of this block diagram here. Now if you try to look into what are the exact functions of each of these parts, then we can try to just list out these functions here. Okay, so let us first take the functions of the CPU. What exactly CPU is going to carry out in this particular microcontroller. Okay, so basically CPU is nothing but a brain of the microcontroller. Okay, it acts as a brain. So it takes all the decisions. Okay, so it processes the data, data. Okay, processing data means what? So sometimes we do the calculation also. So for calculating, so there will be a separate unit in this which is called as arithmetic and logical unit. Okay, so it will carry out the arithmetic and logical operation, okay, on the various data that we are going to give it to the microcontroller. Okay, and the basic function of the microcontroller is to fetch instructions stored in the memory, because whenever we want appliance to do a certain task, so that task will be based on the instruction or the program code that is already stored in the memory. Okay, so if you bring a washing machine, you don't do the programming, it is already stored in the memory, you just want that program to be run. Okay, so the CPU just fetches that set of instructions and it runs the program. Okay, so just like I told you, different you can say washing modes will be there. So those washing modes will be selected because of the instructions already stored in the memory location of that particular microcontroller used in the washing machine. Okay, then once it fetches the instruction, then it also needs to interpret. So what exactly needs to be done? So it needs to interpret those instructions. Okay, so it has to interpret those instructions. So once it interprets means what? The instructions will be in terms of the zeros and ones, so it will understand what exactly needs to be done. Once it interprets what exactly needs to be done, then it has to execute. Okay, so it has to execute. So execution will also be done at the CPU only. Okay, so sometimes we have to carry out that mathematical operation. So for that we have that special circuitry which is called as arithmetic and logical unit. Okay, or most of the time the CPU is used for fetching the instructions, then interpreting the instructions, and then executing the various tasks. Okay, so that is what the main purpose of a CPU. Okay, so then we have the memory. So memory is very important part of the microcontroller. Why? Because if you do not have a memory, then microcontroller cannot perform any task, because it has to store the instructions, okay, and also it has to store the data. Okay, so instructions are nothing but the program codes. program codes. So these program codes are once programmed, they have to remain in the microcontroller all the time till the appliance is used. Therefore, here this particular program instructions are stored in a memory location called as read only memory, ROM. Okay, read only memory. So whatever instruction or program codes are there, so those will be stored in the ROM, and that ROM, the CPU will access the instructions from the ROM depending upon what task it needs to perform. Okay, so if you see here, this memory consists of two parts. One is ROM and another one is RAM. Okay, basic memory locations are ROM and RAM. So now we have that flash memory also, cache memory also. So that we'll see when that particular time comes. So ROM, okay, and then for storing the variables or the data is nothing but variables. So say at a particular time I want temperature of 100 degrees. So this will become say x is variable and this 100 degrees becomes one data. Then next time I want the temperature to be 110 degree. So this is a local or we can say temporary value. Okay, so these are the temporary value. These are not permanent values. So therefore these temporary values will be stored in the temporary location which is called as RAM. Okay, so RAM is nothing but random access memory. So it is nothing but random access memory. Okay, random access memory. Okay, so here it is also called as volatile memory. It is also called as volatile memory. Why volatile memory? Because it is going to store the data for only for a particular instant of that execution of the instruction. Later on that data is going to get erased from the memory location. Once you power off the appliance, so whatever that previous values were there, it will all be lost. Okay, so you have to once again set the new values once you turn on the particular appliance. Okay, and this is called as non-volatile memory, because you turn on the device or turn off the device, so the values are going to instructions or program codes are going to stay in the location. They are not going to get erased or get changed. So therefore it is called as non-volatile memory. Okay, so now this random access. So in this particular context I would like to just elaborate more on this random access. Okay, random access. So what is this exactly random access memory? Because most of the time we hear about it, RAM every time, but what exactly is this? So to understand this random access memory, you have to understand sequential access memory. Okay, sequential access memory. So in the sequential access memory, what happens is, so in a memory, so there will be different locations. Okay, so here set of locations will be there continuously. Okay, so likewise there are so many locations are there, thousands of locations are there. Okay, so now at a time instructions will be executed. So particular instruction will be located in one particular location, say here. So in the sequential memory, so this will be the last accessed memory location. Okay, last accessed. So in the sequential access memory, what happens is, so the whenever next time you are going to access another set of instruction, so the location will be first initiated from this point and then it will go to the required instruction. Okay, so it will take a lot of time. It does consume the time. So here time consumption is more. So to reduce this time consumption, we have this random access memory. So random access means what? Irrespective of what was the last location, so the instruction or the values are going to be accessed immediately without much of the delay in the accessing that particular value. So therefore it is called as random access memory. Okay, so now we have got the third part, which is nothing but the IO ports. So what is the role of this IO ports? So IO ports are used for the for interfacing the microcontroller with the outside world. Okay, so here whatever I have shown, so here different peripherals, we call them as peripherals will be connected to the microcontroller. So it acts as an interface between the, so IO ports acts as interface between microcontroller and outside world. Okay, without this IO port, so we will not be able to give any inputs to the appliance, and it will also not be able to perform any tasks. Therefore, these IO ports are very important. Okay, and microcontroller will consist of a number of IO ports. So based on the required either input or output command, so the IO port can be programmed accordingly, and the port will be used as input or output port. So we use keyboard. So keyboard is a input device. So keyboard, when it is connected, so it will become the input port, and also the monitor, which will display the different values. So monitor or display, so this will be a output port. I am just giving the examples. And also we have a human machine interface, okay, which is called as HMI. So this is HMI is also nowadays used most commonly. Instead of keypad, we use the HMI touch screen, so which is nothing but a input port. Okay, so input port, output port are nothing but basically a set of pins which are used for carrying the digital data. Okay, so from microcontroller, so zeros, ones will be carried out by using these lines. Okay, and at the end, so we have to have a here digital to analog converter whenever we are connecting this particular output, this particular port as the output port, and here in the analog, suppose we want to run a motor. Okay, so we want to run a motor, so motor requires the analog value, and this can give the digital. So we need a digital to analog converter. So using that D to A converter, this motor can be run. So now when you want to increase the speed here, so the values will be changed. So depending upon the higher values, the higher input value will be given to the motor, and it will increase the speed. Okay, so likewise, to connect any sensor, okay, suppose we want to connect any sensor, so sensor will be giving you the analog value, and it needs to be converted to a digital value. So here we have to use a analog to digital converter, ADC. So this analog to digital converter will give the digital value, and these values will be connected, so which are nothing but zeros and ones, to the input ports. Okay, so this will be acting as output port, and this will be acting as input port. So likewise, we can use different devices with the help of these input output ports, and we can give the commands to the microcontroller, as well as the microcontroller can control the various activities of the particular appliance. Okay, so I hope you guys are able to understand what is the basic block diagram of a microcontroller. Okay, so that is it in this particular lecture. So I'll see you in the next video lecture. Till then, thank you all.